Hello guys, in this video, we are going to solve the problem balance a binary search tree. The problem statement is simple. We are given the root of a binary search tree, but the tree may not be balanced. Our task is to return a new binary search tree that is balanced and contains the same node values. If there are multiple correct balanced trees, we can return any one of them. First, let's clearly understand what is given and what is expected. We are given a binary search tree. That means for every node, all values in the left subtree are smaller, and all values in the right subtree are greater. A balanced binary search tree means that for every node, the depth difference between the left and right subtrees is at most 1. Now let's think about the main idea to solve this. A very important property of a binary search tree is this. If we perform an inorder traversal, we always get the values in sorted order. So the first step of the solution is to do an inorder traversal of the given tree and store all node values in a list. After this step, we will have a sorted list of values. Now comes the second part. We need to build a balanced binary search tree from this sorted list. This is similar to how we convert a sorted array into a balanced BST. The idea is simple. We take the middle element of the list and make it the root. Then we recursively do the same for the left half to build the left subtree. And we recursively do the same for the right half to build the right subtree. By always choosing the middle element, we make sure that the height difference stays minimal. This guarantees that the resulting BST is balanced. Let's understand this example carefully. The input binary search tree is 1, null, 2, null, 3, null, 4. If we visualize this tree, it is completely skewed to the right. Every node has only a right child, so the tree behaves like a linked list. Because of this structure, the tree is not balanced. The height difference between left and right subtrees is greater than 1. Now we need to convert this tree into a balanced binary search tree, while keeping the same node values. One possible output is 2, 1, 3, null, 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 4. Here, 2 becomes the root. 1 goes to the left of 2. 3 goes to the right of 2, and 4 becomes the right child of 3. In this new tree, the height difference between left and right subtrees at every node is at most 1, so the tree is balanced. The explanation also mentions that this is not the only correct answer. Let's look at the second example. The input tree is 2, 1, 3. If we visualize this tree, 2 is the root. 1 is the left child, and 3 is the right child. This tree already satisfies the binary search tree property. It is also already balanced because the left and right subtrees of the root have the same height. Since the tree is already balanced, there is no need to rearrange any nodes. So the output remains the same as the input. 2, 1, 3. This example shows that if the given binary search tree is already balanced, we can simply return it as is. The problem gives us a binary search tree that may not be balanced. Our goal is to return a balanced binary search tree with the same values. Let's go through the code step by step. We start with the balance BST function. This function is the entry point and receives the root of the original tree. Inside it, we create an empty list called sorted values. We then call inorder traversal and pass the root and this list. Now let's understand what inorder traversal does. This function performs an inorder traversal of the tree. If the current node is null, it simply returns. Otherwise, it first visits the left subtree, then stores the current node's value, and finally visits the right subtree. Because this is a binary search tree, inorder traversal always gives values in sorted order. After this traversal is complete, sorted values contains all the node values in ascending order. Now comes the second part of the solution. We call build balanced BST and pass the sorted list along with the left and right indexes. This function builds a balanced binary search tree from the sorted list. First, we check the base condition. If the left index is greater than the right index, there are no elements to process, so we return null. Next, we calculate the middle index of the current range. The value at this middle index becomes the root of the current subtree. We then recursively build the left subtree using the left half of the list. Similarly, we recursively build the right subtree using the right half of the list. By always choosing the middle element as the root, we make sure that the tree remains balanced. This recursive process continues until all values are used. Finally, the function returns the root of the newly constructed balanced binary search tree. This approach works because inorder traversal preserves the sorted order of values, and building the tree from the middle ensures minimal height difference between subtrees. Let's run the solution with a few test cases. And yes, it's worked. After verifying the output for different cases, we submit the solution. The code passes all test cases successfully. This confirms that the approach works for both balanced and unbalanced input trees. That's it for this video. We learned how to balance a binary search tree by first converting it into a sorted list and then rebuilding it in a balanced way. This pattern is very useful for tree problems and is frequently asked in interviews. If this explanation helped you, like the video and subscribe to the channel. Given the solution link in description. See you in the next problem.